So for these problems, we're basically simplifying these rational functions. So we have to be really good at factoring, at least for the first problem that we're going to do right now, which if we factor the numerator of this function, we're going to get, so we have our first coefficient is 2x, so I need to have a 2x and an x on the front. And now we have to figure out what numbers could give us for the back number. So I know my back number is 2, so my only options are 1 and 2. So I just have to figure out the combination of when I check it, it gives me the 3x. The only one that I believe works is -1 and +2, because this would give me a -1x and this would give me a 4x, which gives me a 3x. So that works. I did it backwards because I have in the bottom, I have another trinomial that I need to factor. On the bottom, my trinomial is x squared plus 3x plus 2, which again, I'm going to factor it out, and I'm going to have an x on each one because I'm splitting it up. My possible answers for the back number, since it's a +2, that means just 2 and 1, and they have to both be positive because I need a +3, so +2, +1. And I'm going to see if there's anything I could reduce on the numerator and denominator, and there is. These two reduced right here. And when I reduce something in numerator and denominator, that actually becomes a whole eventually if we're graphing it. So we're going to have 2x minus 1 and x plus 1, and this would be my simplified function. What our removable discontinuity would be, since I had canceled the x plus 2 and both the numerator and denominator, that means I'm going to have a discontinuity at x equals -2. What are my non-removable discontinuities? I'm going to look at my denominator, and I have x plus 1. So that means my vertical asymptote is going to be x is equal to -1. That's my vertical asymptote. I didn't really ask you for the y-intercept, so not put it in there. But if it is, your y-intercept would have been 1/2 comma 0, because you're just solving for this part right here, which is the numerator. So for this function, I'm going to factor out the greatest common factor here. I'm going to factor these other 3 trinomials into a binomials. So I'm going to have factor out a 6x, and I'm going to have x plus 3. And on x squared plus x minus 6, I'm going to factor that into 2 binomials. And since the back number is -6, I'm going to have a negative number and a positive number because I need a positive x. So that means I'm going to have +3 and -2. For my top trinomial, again, I have a -2. And I need -1, so my options are going to be 2 and 1. And since I need a negative, one of my functions has to be negative. And since I need my middle term to be negative, that means my bigger number has to be negative. So I'm going to have x minus 2, x plus 1. Same kind of concept in the bottom, so I'm going to have x minus 8 and x plus 1. And then I'm going to see if I have anything that reduces in the numerator and denominator. These reduce, these reduce, these reduce. So that means on the numerator, I'm going to have 6x. On the denominator, I have leftover x minus 8. Those x's cannot reduce because there is a minus sign that is attaching those together. It is not a binomial or anything being multiplied. For part A, what are my removable discontinuities? Since I canceled these, I have x equals -3 as a discontinuity. I canceled these two, so I'm going to have +2. And I canceled these, so I'm going to have -1. So my discontinuities are -3, +2, and -1. My non-removable ones, if I'm looking at my denominator right there, it would be x is equal to 8, which is my vertical asymptote, just FYI. And then that's it. So on this one, if you notice, it's a division. So we're going to do a little extra step besides. It's very similar to the one that we just did it previously, but with one extra step. which is we're going to take the reciprocal of the second fraction once we simplify it, I guess, or after. So on the numerator, I can't reduce anything or factor out anything, but on the denominator of the first one I could take out a 9x, and I'm going to have 9x x minus 2. I'm going to change the division sign to multiplication, and I'm going to take the reciprocal of the second fraction before I factor it out. So I'm going to have x squared minus 5x plus 2 and 2x squared minus 11x plus 5. My next step is x minus 5, 9x, x minus 2. And I'm going to factor the top. Since my leading coefficient is 2, the only way I could get that is if I have a 2x and an x. My back is a 2 also, so that means the only options I have for my back numbers are 2 and 1. So either I put 2 here or 2 here, but it does make a difference. I think I put -1 here and a -2, sorry. -2. And that should work because that would give me a negative x. That gives me a -4, -4, -x, -5. That works. Same thing for the bottom. I'm going to have a 2x and an x. I need a 5 and I need 11. So that means I need a 10 and a 1 to get the -11. And they both should be negative because I need -11. So I'm going to have -5 and -1. That should work. And now I'm going to look for anywhere where I could reduce things. I could reduce these two right here. Oops, let me do a different color. I could reduce this. I could reduce this one and that. So that means in the numerator, I got left a 1. In the denominator, I got left a 9x. So this is my function. My removable discontinuities are x is equal to 5, x is equal to 1/2, and x is equal to 2. My non-removable discontinuity is just the bottom part, so that would be just x equals 0. For this problem, I'm going to let you try it out, but I will give you the answer. I'm not going to work it out for you, but I will give you the answer. The answer should be x plus 3 over x plus 2. So that's the answer that you want to get. So I'm going to let you work that out, and if you get that answer, you did it correct.